The calculation addresses determining service entrance conductor and feeder sizes for a school and book storage warehouse. The service entrance is specified as 480 over 277 volts, 3-phase 4-wire. The calculation is broken down into determining the load for the school area, then the book storage area, and finally combining them to determine the service entrance conductor size. Afterwards, a feeder for the warehouse is calculated. Within the school area, the lighting load is considered. There are 550 fluorescent fixtures rated at 180 watts at 277 volts. For lighting, a continuous load factor of 80% is applied. This results in a continuous lighting load calculation of 550 fixtures multiplied by 180 watts multiplied by 0.80, which equals 79,200 watts. Other loads in the school include 400 120-volt duplex outlets. These outlets are calculated at 1 amp each, yielding 400 outlets multiplied by 120 volts multiplied by 1 amp, which equals 48,000 volt amps. There are 50 power pole outlets rated at 250 watts at 120 volts, giving 50 outlets multiplied by 250 watts, or 12,500 volt amps. Additionally, there are 400 feet of multi-outlet assembly. It is assumed that 50% of the outlets will be in use simultaneously. Therefore, the calculation is 400 feet multiplied by 120 volts multiplied by 0.5 amps multiplied by 0.5, which equals 12,000 volt amps. There are 4 15 kilowatt range outlets totaling 4 multiplied by 15 kilowatts, which equals 60,000 volt amps. 3 5 kilowatt dishwashers are present. The calculation is 3 multiplied by 5 kilowatts, or 15,000 volt amps. 2 10 kilowatt hot water heater boosters result in 2 multiplied by 10 kilowatts, which equals 20,000 volt amps. 4 2 kilowatt disposals are installed with 4 multiplied by 2 kilowatts, which equals 8,000 volt amps. 4 1 kilowatt toasters giving 4 multiplied by 1 kilowatt or 4,000 volt amps. 4 3 kilowatt food warmers are present with 4 multiplied by 3 kilowatts, totaling 12,000 volt amps. The non-continuous lighting load is the remaining 20% of the lighting load, so the calculation is 550 fixtures multiplied by 180 watts multiplied by 0.20, which equals 19,800 watts. The total school load is the sum of the previously calculated values, resulting in 79,200 watts plus 48,000 volt amps plus 12,500 volt amps plus 12,000 volt amps plus 60,000 volt amps plus 15,000 volt amps plus 20,000 volt amps plus 8,000 volt amps plus 4,000 volt amps plus 12,000 volt amps plus 19,800 watts, which equals 391,500 volt amps. The book storage area has 100 120 volt duplex outlets. Assuming 1 amp per outlet and applying a continuous load factor of 80%, the calculation is 100 outlets multiplied by 120 volts multiplied by 1 amp multiplied by 0.80, which equals 9,600 volt amps. 12 1/2 horsepower 120 volt blower motors are used for gas-based heaters. Converting horsepower to watts and summing gives 12 blower motors multiplied by 0.5 horsepower multiplied by 746 watts per horsepower, which equals 8,952 watts. The total book storage load is 9,600 volt amps plus 8,952 watts, totaling 18,552 volt amps. The total facility load is the sum of the school load and the book storage load, resulting in 391,500 volt amps plus 18,552 volt amps, which equals 410,052 volt amps. To calculate the service entrance conductor size, the total volt amps are divided by the voltage and the square root of 3. Therefore, the calculation is 410,052 volt amps divided by 480 volts multiplied by the square root of 3, which equals 487.77 amps. Applying a safety factor of 1.25, The ungrounded conductor size is 487.77 amps multiplied by 1.25, resulting in approximately 610 amps. To calculate the feeder size for the ungrounded conductor to the warehouse load is calculated as the sum of the school and book storage area, which is 391,500 volt-amps plus 18,552 volt-amps or 410,052 volt-amps. To determine the feeder size, the total volt-amps are divided by the voltage and the square root of 3. The calculation is 410,052 volt-amps divided by 480 volts multiplied by the square root of 3, which equals 487.77 amps. Applying a 1.25 safety factor to the feeder for the ungrounded conductor results in 487.77 amps multiplied by 1.25 or approximately 610 amps.